going to have more of these decomposition and combination reactions along with the next type of reaction we're doing, which is single replacement. Okay. So, about this time, I'd like to use an analogy for our types of reactions. Okay. So, you can think of a combination reaction. My analogy is going to be dance. Okay. You can think of a combination reaction as the beginning of a dance. Start off with two separate people. They come together and make a couple, a compound. Okay. You can think of the decomposition as the end of the dance. The music stops playing, got a couple on the dance floor, they go their separate ways. Okay. So either come together or fall apart. Okay. In single replacement, one element replaces another. So in my dance analogy, that would be like, got a couple on the dance floor, somebody comes up and taps on the shoulder and says, mind if I cut in? Then you've got, after they've cut in, you've got a new person standing by themselves and a new couple on the dance floor. So I started off with one couple and one person standing by themselves. I ended up with a new person standing by itself and another couple. Okay? Standing by itself is an element. A couple is a compound. So in a single replacement reaction, one element replaces another. So for a single replacement reaction, you have to have something to replace and something to be replaced. So you have to have something to do the replacing, an element, and you have to have something for it to do the replacing in, and that's a compound. You got to have a single one and a couple. You got to have an element and a compound. Something by itself, something put together. So I start off with an element and a compound. And when I'm done, I've got a different compound, and I've got a different element standing by itself. So I start off with one element and one compound. I end up with a different element and a different compound. For example, here's a single replacement reaction. Sodium reacts with potassium chloride to make potassium plus sodium chloride. So I have an element by itself, sodium, and a compound, potassium chloride. I end up with a different element and a different compound. Yeah, Corey. Okay, metals replace metals, and non-metals replace. So how did I know Na was going to replace K? Well, Na is a metal, K is a metal. Metals replace metals. Okay, because I was about to make the next point. If my element is F2, a non-metal, when it reacts with a compound, LiCl, it doesn't replace the Li because F is a non-metal. Non-metals replace non-metals. So the Li takes the place of the Cl. So Cl gets kicked off by its own, but Cl can never be by itself, so it gets a 2. And the LiF is that Li is 1 plus and F is 1 minus. and then we would take the time to balance that. Okay, so it's the same process. The name is single replacement. You do what it says, single replace. Then you figure out the formulas. Does my element need a 2? My compound, I need charges. Then balance. Okay, so it's that same process. Do what the name says, figure out the little numbers, balance. So to balance that, I would have to have 2F, so I put a 2 in front of LIF. That gives me 2 LIs, so I put a 2 in front of LICL. That gives me 2 CLs, which I wanted anyway. Okay, so here's our first reaction. Here's our couple, KCl, and our person by himself, sodium. And the sodium is going to kick the potassium off. And now I end up with a different couple and a different person by themselves. For the other one, fluorine you got to treat special because fluorine is twins, right? So fluorine, the fluorine twins kick the chlorine twins off. Make sense? Okay, so we saw it in those examples, but now here's in writing. Metals replace metals, and metals replace hydrogen. Okay. So, for example, magnesium and copper 2 sulfate. Okay, so don't take the tripod off the edge. So here I have a solution of copper 2 sulfate. Camera to work. Okay, so it's a nice blue. That's the copper 2 ion, is always blue. That's how we recognize it. One more piece, there we go. Okay, and to that, I've got a piece of magnesium. Strips of magnesium. This one comes off. There we go. So I'll take a strip of magnesium. And we'll drop it in the test tube. Too packed with more sugars here. Okay. So it's just sitting there. In the water. There we go. Okay. You see it's reacting and solid pieces are falling off, right? Well, what's going on there? You see the solid pieces react, there's solid pieces falling off. A few bubbles, but the solid pieces falling off. Well, what's going on there? Well, we're going to do our single replacement. Okay. So on our single replacement, magnesium is going to replace copper. So magnesium will end up next to SO4, and copper will be by itself. Okay, so I did what the name says, single replaced. Then I worry about subscripts. Copper's by itself. When copper's by itself, does it need a little 2? Is it one of our diatomics? 1 to 7? No. Okay, Magnesium is a group 2A, it's 2 plus. I look up sulfate, it's 2 minus. Those add up to 0. So that's the right formula for magnesium sulfate. Oh, what the heck happened there? Where's the exit button? Over there. SO4 is 2 minus. Mg is 2 plus, SO4 is 2 minus, that adds up to 0. And then I balance it. And this one balances easy. 1 Mg, 1 Mg, 1 Cu, 1 Cu, 1 S, 1 S, 4 Os, 4 Os. We're done. Hmm? What if I had put aluminum into copper sulfate? The aluminum will do the same thing. Aluminum will push off the copper and end up next to sulfate. And copper will end up by itself. I did the single replacement. Okay. Then I figure out the little numbers. The Cu need a little 2 next to it. Well, SO4 is 2 minus, Al is 3 plus. So we can do the crisscross. 3. So I do my crisscross, get Al2, SO4, 3. Okay, so I've done write the formulas. Now I balance. 2 Al, so I put a 2 in front of Al. 3 SO4, so I put a 3 in front of CuSO4. 3 S's, 12 O's. 3 S's, 12 O's. And 3 coppers, so I put 3 in front of copper. So in both cases, if I used aluminum instead of magnesium, I'd still see a solid. I'd still have the solid copper come out. Yeah, so those chunks you see falling, boonk. Yeah, it's catching some bubbles. It's reacting a little bit with the water. We'll talk about why that happens. But all those little black pieces you see floating around are little tiny specks of copper. Okay. Because the magnesium sulfate dissolves. Okay. So what about zinc and H2SO4? Okay. Well, zinc is a positive piece, so it's going to replace hydrogen. So zinc will end up by itself, or zinc will end up next to sulfate, and hydrogen will end up by itself. Okay, so I did what the name says. Now we decide on subscripts. Does hydrogen get a 2? Yes. Okay, I know SO4 is still 2 negative. Zinc, I look up zinc on my periodic table, it doesn't do me any good. But that's because it's on your polyatomic ion list. That zinc always makes a 2 plus ion. So if zinc is 2 plus and SO4 is 2 minus, that adds up to 0. And we have to balance it. Okay? So, use my flask. Okay, so here, I have some H2SO4. And into that, I am going to throw, oops, back. Into that, I'm going to throw a few pieces of zinc. And those pieces of zinc bubble away. Wrong way. Okay, so that's bubbling away. So, what are those bubbles supposed to, what are those bubbles? Well, what does the equation say those bubbles are? Bubbles, the equation says those bubbles are hydrogen And we have a way of figuring out whether it's hydrogen. Because we know one thing about hydrogen. Hydrogen is flammable, right? So if this is hydrogen, I should get a flame. And I did. So it's not just letters on a screen. We can see the hydrogen gas being given off. You notice this isn't as blue anymore. It's changed colors. That's because the stuff that was making it blue, copper, is going away. And magnesium is coming in. Magnesium ions and copper ions are different colors. So the blue will go away. I'll end up with a pile of metal on the bottom. Okay. Now there's something else with H that we got to treat special, and that's water. Another potential name for water is hydrogen hydroxide. See, that would be water, 2 H's and an O. If I do the structure, the H's would be off the sides, right? So we want to think of water as hydrogen hydroxide. And that's because hydrogen hydroxide, that metals only replace one of the hydrogens, and they end up next to the hydroxide. So with H2SO4, I took the place of both metals, both H's. But with water, it only takes the place of one of them. I wonder if that's hydrogen. Yep, it's hydrogen. It's actually still burning. So, if I put some sodium in water, okay, the sodium is positive. It's going to replace the positive piece. It's only going to replace one of the H's. The other one's in the compound because OH is a polyatomic ion. Okay? And then the H is by itself. Okay, so now we did what the name says. Now we go one. Can H be by itself? No. The charge on sodium, it's in column 1A, so it's 1 plus. Hydroxide is 1 minus. So that's the right formula for sodium hydroxide. It's got 3 on the right and 2 on the left, and that's the only thing that's messed up, and it's even and odd. When it's even and odd and it's messed up, put a 2 in front of the first one. That gives me 2 NAs. That'll give me 2 NaOHs, which gives me 2 O's, so I got to put a 2 in front of water. It gives me 4 H's there, and there's 4 H's on the other side. So it's still that same pattern. Do what the name says, figure out the subscripts, balance. Okay, now, single replacement is different than the other ones because we can tell before we mix the chemicals whether a reaction is going to happen. Okay. In my analogy, if a senior tapped a freshman on the shoulder and said, "Mind if I dance with your date?" they're going to switch partners. But if a freshman tapped on a senior's shoulder, "Mind if I dance with your date?" there's unlikely to be a change. Does that make sense? So seniors replace freshmen, but freshmen can't replace seniors. Okay? Well, the same thing happens with metals. Some metals are like seniors. They're more active. Some metals are like freshmen. And then there's sophomores and juniors in between. Understand the analogy. Okay. So more active replaces less active. So high school, you know who's in what class based on what their English, what grade they're in based on their English class, right? Well, we have a list. It's that list right there. It's on page 33 in your textbook. Okay? That's where I got it from. It's called the activity series of metals. Okay? The top of the list is the most active. The bottom of the list is least active. The top of the list is seniors. The bottom of the list is freshmen. Okay? So higher on the list replaces lower on the list. So if the element by itself is higher, it happens. If the element by itself is lower, it doesn't happen. So if you think about the situation, senior standing by himself, a freshman in a couple, there's going to be a change. Freshman standing by himself, senior in the couple, nothing's going to change. At the end of the dance, you're still going to have the senior and the freshman still going to be standing alone. So if it's higher, it happens. So let's look at a couple of examples we can do. Like, here's our list. We did copper and magnesium. Notice that what I put in was the magnesium metal, and it could knock the copper off. You do not have to memorize this list, you just have to be able to use it. Yeah. Not about how fast, that's more surface area. It's more to degree. Okay? And I said, we put together zinc and hydrogen. The zinc was above the hydrogen, so I could push it off, and I got hydrogen bubbles over there, because we can all tell it's hydrogen, right? So we all know it's hydrogen. Okay? So the reason why this happened was, the reaction I show you happened is because magnesium was higher than copper, so I pushed the copper off, out of the couple, and the zinc was higher than the hydrogen. Then there's that little asterisk. And this is what the little asterisk says. Metals from Li to Na. So if we're looking at this, it's the top part, Li to Na. Let's change the color. Li to Na, those top four, will react with acids and water. From Mg to Pb, they'll replace it from acids only, and acids are things that aren't water that start with H. So you'll notice that acids gets mentioned with everything, and water only gets mentioned with the top ones. So you can think of water as a committed couple. Okay? A couple of sophomores that are really committed to each other. It's got to be a really big senior before they're able to break up that couple. Okay? So H can be replaced in acids, which is anything that starts with H that's not water. So it starts with hydrogen. Okay? And only the first four, lithium through sodium, react with water. And we actually did this experiment. We put calcium in water. Remember put calcium in water and it bubbled out of there? We're trying to see which kinds of metals reacted with other ones. The calcium reacted with the water and the acid, and it bubbled a lot. Okay, so now before we do everything, this one stop, is it going to happen? Okay. So now sometimes the answer is nothing's going to happen. Fe and CuSO4. So I need to look up Fe and Cu on my activity table. Fe is right there. Cu is there. Is the one by itself higher or is the one by itself lower? One by itself is higher. It does. So this reaction, so we're trying to decide, is this reaction going to happen? Yes, because iron is higher than copper. So Fe is going to end up next to SO4, and Cu is going to end up next by itself. Now there's a problem here, and it's one you can't solve without me telling you something. And that is, what is the charge on Fe? Sometimes it's 2 plus, sometimes it's 3 plus. We don't know which one, and I'd have to tell you which one. Does that make sense? So this time I'm going to tell you it's 2 plus just to make our life easy. Makes balancing it a little faster. And if it was the 2 plus, it'd be balanced already. Because that's the right formula for FeSO4. Okay? Cu doesn't need a little 2. SO4 is 2 minus. Fe is 2 plus. That adds up to 0. Then we balance 1 Fe, 1 Fe, 1 Cu, 1 Cu, 1 S, 1 S, 4 Os, 4 Os. Pb plus KCl. So I find them on the table. Pb's here. K's there. Would that reaction happen? Can lead push potassium off? No, so that would be no reaction. And sometimes that's important. I now know I do not want to make a boat out of those top 4 metals. Right? Be kind of ineffective. Okay. Al plus HCl. Well, A is a metal, it's going to push off the H. Can it? Well, let's look at the number. Al is here. H is here. So the Al is going to end up next to the Cl, and the H will be by itself. The one by itself, does it get a little 2? Yep, because it's hydrogen. Chloride is in group 7A, so it's 1 minus. Aluminum's in group 3A, so it's 3 plus. It's got to be AlCl3. So I did what the name says, sigma replaced, figured out the little subscripts, now I have to balance. So if I fix the C's, I put a 3 here to get my 3 Cl's. But it gives me 3 H's on one side and 2 on the other. And so I put a 2 in front of the Al, way back to the front. That gives me 2 Als. So I put 2 in front of AlCl3, that gives me 6 Cls. So I put a 6 there. Now I got 6 H's, so I can put a 3 in front of H2. And that gives me 2 Als, 6 H's, and 6 Cls on both sides. Oops. Aluminum and water. Aluminum and water, we're worried about the H. says aluminum is higher than water, but H, hydrogen, has that little asterisk next to it. Always be careful with hydrogen, because it says the top four can react with water, and all of them can react with acids. So what am I reacting with? Water. So there is no reaction here. It's higher, but it's not high enough. Water takes a special one. And you kind of know that because otherwise, aluminum would react with rain. Doesn't happen, does it? Would never want to cook anything in an aluminum pan, would you? If aluminum react with water. Fact is, I learned something about aluminum reacting when with my first job. My first job, I worked for a pizza place, and I was the only employee. It was really tiny. Everybody else was family. And we made our own sauce. We made our sauce in this big aluminum stock pot. So we pour in tomato juice and tomato puree, spices, salt, and we'd stir it up, and then we pour it into separate containers from there. Well, I noticed a problem. My table where I was making the sauce always got dirty, and where it was getting dirty from was the sauce was leaking through the side of the aluminum pot. Because tomato sauce is acidic. So aluminum reacts with tomato sauce, and the aluminum goes into solution, and it makes hydrogen bubbles that go away, and it eats away at the aluminum in the pan. And over time, it had eaten a hole all the way through the pan, so to the point where the sauce was leaking out the side. So you never want to cook tomatoes in aluminum. Tomatoes and tomato sauce are all acidic, and they react with the aluminum. What does it mean that Ag is on the bottom of the list? Now, this isn't a complete list. You may see one, I'll give you a different one that's a little bit longer. It includes more metals, because I know it for all of them, right? These are not the only metals that react. They got the whole list. Okay, what does it mean that silver's on the bottom of the list? Well, that means it's a freshman. And no matter what dance you go to, the freshman always ends up alone. So silver doesn't react with stuff. If we had put more elements, there is something below silver. Gold. Gold is below silver. Okay? It's really about a fight for electrons, but what that tells us is that silver and gold don't react. And that's why we make two things out of them. One of them is jewelry. You would not want jewelry that reacted, because it would not be shiny for very long, right? And if you stepped out into the rain, bad things could happen. In fact, is oftentimes you know your jewelry is not pure gold or pure silver because it starts turning stuff green. And green is either copper or nickel, which is higher up on the series, so those do react. And they're reacting with the acids and oils in your skin. Okay, so that's what's going on with your ring does that. The other thing they used silver and gold for was money. Right? Up until 1971, every U.S. dollar had a dollar's worth of gold in Fort Knox. They actually had a pile of gold that was worth all the money that the U.S. economy had printed. Yeah, it's really big. But now we've gone to just trust us, our money's worth it. So they don't have to keep as much gold. But why do they use gold for money? Why do they use silver for money? Because it doesn't change. Do you want to use magnesium for money? Well, if you spill a tomato drink, you now have less money. Okay? That's why when you go back and look at the we show old movies about old westerns, they show people biting coins to see if they're good. That's because silver and gold are malleable metals. So if it's all gold or all silver, you can leave a tooth print into it. You can bend the coin. But if you try to put any impurities, you've made an alloy, and that's harder. So you can't bend it. You can't leave a toothprint in it. And you can feel the difference between pure gold and non-pure gold. And you want pure gold for your money. Okay? So the bottom of the list means it always ends up alone, so it doesn't react, which is why we make our jewelry and our money out of it. Because we don't want money that goes away, that disappears. And we don't want jewelry that doesn't stay shiny. Okay. So we'll stop right there.